Hello and welcome back to KXAM Plus. I am your host, Esmeralda Zamora, and today we have our space-based show with our KXAN space expert, Eric Henriksen. Eric, thank you for joining me. How are you doing?
I'm doing excellent. How are you doing today?
I'm doing good, and we're both celebrating, what was it that you had just told me?
It is World, I'm going to make sure I say it, it's World Space Week, I believe is what
World Space
World
Week.
Space Week.
Interesting.
You know how we totally dig World Space Week.
Well, we're here to celebrate
at KXAN.
with a cool topic, right?
I think we're talking about eating. A lot of eating today.
And a baby planet, right?
Baby plants that are eating things. That's
Oh.
I was tying it all into the food part. I guess baby plant was the other way to talk about growth. We're talking about growth on today's show. Yeah, that's the topic.
The growth of a baby planet
Right.
that has been photographed, and we have the photograph,
Yes.
right?
Yeah, pop it up. We have this animation here. So there's this baby planet. Its name is WISPIT2b, or let's call it Wispit, shall we? Wispit.
It sounds like a little Pokemon.
It's Wispit. Oh, go catch Wispit. There's a couple renderings, and then you'll see the photo here as it pops up a second. You saw it just a second ago. Here, I kind of have this rotating for y'all. There's the actual photo of Wispit. So what's Wispit? Wispit is a star. It's about 500 light years away, 437 light years, being orbited by Wispit 2b. And Wispit 2b is who we're talking about. Wispit 2b is a protoplanet, a baby planet, 5 times the mass of Jupiter, but it's only 5 million years old. Now, for perspective, Earth is 4.6 billion years old.
Yep.
So it's about 1,000 times younger than Earth is. So it's a baby planet. And what's interesting about it is, so you see that ring that's right there? That ring right there is called the protoplanetary disk, and it's this cloud of gas and debris that orbits a star as a star forms. It's kind of like the leftovers of a star. And this planet has been spotted orbiting in the dark space of that. And what they think this protoplanetary disk is, we actually have an animation of that too we can show. What people think this disk is what the materials planets are made out of. They're made out of this disk. So as a star forms, gas collapses and collides and gets denser and denser and forms like this kind of gravitational crunch.
It looks like a cloudy
Yeah.
ring around it.
So the star gets tighter and tighter, and then when it reaches its equilibrium phase and becomes a full actual star, all that gas is released and forms this ring of dust, this protoplanetary disk. And this orbits the star. And within that, scientists have long expected that planets form. Well, this image that we have now is proof of that. So this is that forming I mentioned as the disk forms. And so this planet, as it's...
Oh, that's the wrong picture.
What was that? I know what that's for. Totally different, unrelated. So as this disk forms, the planet forms within it, and now with this new photo, we actually see that this dark ring that we have a photo of for the first time with this planet in it is the ring left over likely as that planet ripped away at that gas and dust and formed into its own planet.
So how were scientists able to capture that image that we saw?
They had two telescopes. I always say satellites, I mean telescopes. 2 telescopes, both in Chile. The one is the Magellan Telescope. The other is one owned by the University of Arizona. Mm-hmm. And the Magellan Telescope got the initial data for it and located the star. And the University of Arizona's telescope, it's also in Chile, but it's owned by the University of Arizona. Details. It was able to capture the image. And it's an image. It's not actually a picture. It's an image with data and stuff. But closest to a picture we have of this star. And planet, and the planet rotating around the star. So pretty neat, right? What also is interesting is there's another dot that they expect in that, they suspect in that ring is actually another planet that's being formed. So we've never spotted these planets forming in these disks before. And yeah, this is the first time. Pretty cool, right?
Yeah, well, you talked a little bit about these planets eating or absorbing one another. Is that what this star is doing?
It's like a snowball rolling downhill, except
like
instead of downhill,
it's on its way.
Right, and as it goes around the ring, which is its version of downhill, it collects more and more snow, in this case dust and sand and gas, and forms into a planet. So it's like goes around a circle and gets bigger and bigger and bigger and bigger, and eventually there's no more snow on the slope for it to collect. It's just empty space, and that's when you have a planet that's orbiting. If you look at our own solar system, you know how the planets move in rings.
Yeah.
It's likely that in these orbits that each one of those was a ring that it passed through and then formed its thing. And then we have the asteroid belt, which isn't like super dense. I know people think like asteroid belts like Star Wars, where there's hundreds of asteroids.
Full of
Wherever you look,
asteroids.
there's hundreds of asteroids. Nah, they're like really far apart, but that's like leftover debris from that from likely our ring is what they think. So this ring, this image is the first signs. Oh, look, there's planets forming in these dark spots, and that's where that formed.
And how does this specific baby planet compare to our planets in our solar system?
Well, it's significantly younger. So like I said, 4.6 billion years old is how old the Earth is. This is about 1,000 years old.
Oh, wow.
Or yeah, no, sorry, 5 million years old. So 5 million. It's 1,000 times younger than us. So 5 million years old compared to our, 4.6 billion years old. So very, very young. But we're also not that old of a planet, really. Not really. So on the scale of things, both pretty young. In the scope of the universe.
There was a lot of talk about this being a significant discovery.
Mm-hmm.
Why are they saying that this is such a significant discovery?
Well, we haven't seen this before. So now this is proof of an idea. Not proof, but like evidence of an idea, the hypothesis that we've had. And now that we have this evidence, it's likely occurring again. So this is likely how solar systems and planets form. And now we've actually spotted it. So pretty cool. That's why it's significant.
And what are scientists hoping to learn from the next discovery of a planet like this or this one specifically?
So they had that other dot they saw within this ring. So that could mean there's another one there, and then we can maybe watch this specific spot of space and see more how quickly this occurs. This process occurs. Yeah.
Wow. Yeah, that's interesting. I'm sure. Do you think that there's a lot more like this out there, or
I would suspect, with my limited expertise, that this is how most planets form. This is my guess.
So that's how Earth was formed,
likely,
pretty
yes.
much.
Yes, that would be my guess.
And do they stay with that little cloudy ring around them, or does that eventually
Well, it eventually forms into more planets, possibly,
Mm.
or asteroid belts like we have. So that's what we think. So you have more and more and more and more forming over time.
Mm.
Billions of years is what I'm saying in time. Nothing that we could comprehend.
In my brain, I'm thinking like one planet is starting with this cloud or ring, and then it eventually absorbs, or new planets grow, and that's just one solar system out of that one thing.
Yeah, it's multiple planets within that and forms a solar system. So yeah, it's like I said, it's like multiple snowballs rolling downhill, and they're all collecting snow as they go, and eventually
Staying
the whole
together.
mountain has no snow, but you have all these snowballs, and so
Wow.
there you go.
Well, that's cool. Honestly, that's a cool baby discovery, and I'm glad we got a photograph of it. It's really pretty.
Right, and then the renderings are solid too. That shows you kind of basically what's happening there as it's passing around within these rings. And yeah, it's the blue dot on the right. That's what you're looking at.
Is that really what it looks like? Like a little glowing ball?
Yeah, it's hot.
Wow.
Plants are hot when they form. They're not cold. They're hot. They're magma-y, fiery and stuff. Yeah.
Not
it's
Earth.
like, have you ever done any blacksmithing?
No, not in my lifetime.
Well, when you mold, let's say a sword, because I'm playing a video game where you do swords, you heat it up and it gets molten, and then you hammer it. That's basically what happens. So you have to get it molten, and then it forms into a ball.
So it gets hot, and then it forms itself into a ball?
Well, yeah. I mean, it collects all the dust and debris and stuff as it hits it, and as it forms that kind of collides and melts, and then as there's less stuff colliding against it, which creates heat, it cools down, and then it becomes a planet.
Wow. Sometimes our scientists or whoever's in charge of naming these planets come up with some crazy names, but this one is pretty cute.
Wispit 2b, yeah. I'm actually thinking that's kind of cuter the more I say it out loud, because I read it as Wispit
Oh my gosh.
2b, because that's what its name is.
Yeah.
It's it's the usually where it's found, location, by what telescope and who finds it. It's kind
But
of
Wispit is cuter.
Wispit much cuter. Wispit's a
Much
lucky
cuter.
one.
Yeah.
Wispit's up there with Pluto. Pluto's a cute name,
Yeah,
even though
and
it's like the
Pluto's
god
a
of death
cute
or
little
something.
planet. What?
Yeah, no, Pluto is the god of death
I did not
in
know
Roman.
that. Why did they name Pluto that?
Or did they name the god after Pluto?
Oh,
But no,
you're
I think they named Pluto after the god.
right.
I
Well-
think that's how that works. You're not big on your Roman mythology, are you? Hades would be the Greek version. Yeah.
Of Pluto?
Yeah.
Mm.
The Romans stole the names stole the gods, the deities from the Greeks, and then altered them a little bit. Yeah.
We need to do a whole in-depth on
Should we talk about mythology? This show
We
become a
need to
mythology
create
show?
another mythology show and
I
just
could
talk about
dive in.
that.
I could dive in. Do you want to talk about something else that's cool?
Yeah, we
Another
have
planet.
another planet.
This one's also eating stuff. This is a rogue planet.
This one's also eating stuff.
Yes, this is my whole philosophy on today's show for World Space Week, is that we're just talking about eating. Am I hungry? Yes. Do I want to eat food right now? Yes.
Maybe you need some breakfast after
I do
this.
need breakfast. I haven't had breakfast yet, and all I've been doing is talking about planets eating things all morning. So let's talk about this rogue planet. This one, you're gonna hate the name. You ready for it?
I'm looking down to see what the name is, and
I read
it's
it
crazy.
down. CHA, CHA, 11077626. We're just gonna call it.
Cha-cha.
I was gonna call it Rogie.
Oh, that's cute.
You want Rogie or Cha Cha? What's your preference?
Let's do Rogi Cha-cha.
Rogie Cha Cha. Rogie Cha Cha is a rogue planet, which means this does not orbit a star. It's just kind of like out there, collecting gas and stuff the same way a star does, same way this last planet did. This is a cool animation from the European Space Organization. And this thing is gulping down dust and gas, just like the last planet we talked about, at 6 billion tons per second.
Whoa.
So it is a hungry boy. Rogi Cha Cha is a hungry, hungry planet. 6 billion tons per second. Now it's a little further away than Wispit 2b. It's 620 light years from Earth. So remember, Wispit is about 400 light years from Earth. So this one's quite a bit farther away. Not another 200 years or so. It was seen by James Webb Space Telescope and the Very Large Telescope, which is the VST or VLT. Another large telescope we have, which that one's actually my favorite telescope name. It's like, what is it? Well, it's a very large telescope.
Yeah.
Yeah, 6 billion tons per second. It's the fastest a planet forming that we've ever seen for a
Why is
planet-sized
it
object.
classified as a rogue planet? Like, what
Because
makes it a
does
rogue?
not orbit a star.
Oh, wow.
So there are planets out there that are just floating around,
Just doing their own thing.
that are flying through the universe, and they do not orbit a star, which means they're not being locked into an orbit, which means they could theoretically fly through our solar system and we would not even know they're there.
Or they could possibly hit us.
I wasn't going to say that, but yes, there is anything can hit us, but there is a possibility they could hit us.
Well, that rogue planet
And it
has
would wipe
a more
us out.
chance.
But
What?
Yeah, but this is again 600, almost 600 light years, 620 light years away from Earth, is not near us at all. We're fine. But 600 billion tons per second, so it's growing fast. It is 5 to 10 times larger than Jupiter.
Oh my gosh.
And let me see. I have other cool facts about it. It's possibly, this is my one cool one, driven by a magnetic field is helping accelerate this growth. The scientists who studied this from the European Space Organization, they talked to the Associated Press, and this is what they had to say about their discovery.
This is what we were studying at this point. We were trying to study how fast is the rate of material getting into the object. And what we suddenly found is that there was a very strong growth of material that was impacting the central object. And when we saw this, it's when we realized that it was a very special phenomenon. This is the first time that this kind of phenomena has been observed in such a low mass object. So we will definitely follow up this object because we have observations from this object from almost 20 years ago and 15 years ago, and we see a similar behavior. So there's indications that this is a recurrent event. Now we need to understand how recurrent, how important, how long lasting, because we didn't get an idea of the full duration of this burst. We just had a lower limit, let's say, because after 2 months, we couldn't continue it observing. So it could be possible that the object is still in this, during this enhanced accretion phase.
Wow, so he said this is a significant discovery, but after 2 months, they were not able to observe it anymore.
Right. Because they usually, like, these, the way the observations at work is they kind of rent out the telescope for a time.
Oh, so they have to use it for as much time. as
Yeah,
they
it's usually you
rented
kind of mark yourself down on like a time card schedule thing.
it.
I've talked to a lot of scientists about this. It's like you can pick up this telescope for these days for these hours. That's what you have obtainable.
And you have
'Cause-
to do your research within that amount
It's
of
all
time.
high demand. You can usually rent, like James Webb. I think it's like they rent out. Like we want to take a photograph of this section of the sky, and they'll do it. And then a bunch of other people will say we also want to do that section, and so there's a bunch of people using that section.
And they
at the
don't
same
just
time.
share the photograph if they're doing the same section?
They may need different scans or something. They may they may share it. They may need different scans, stuff like that. So it kind of depends on what the scientists need. So yeah, they had a limited time, but they do think this is occurring. Like it's possible is that what it's doing is slowing down and then speeding up every 15 to 20 years. So it could enter like this phase where it's doing 6 billion tons per second of pulling in matter, material, and growing as a planet.
What's the purpose of it, like growing that large?
It's just a planet. It's just growing.
It's just trying to absorb as much as it can.
Yeah, it's like when I eat too much protein, it's just I'm just
You're
trying.
hungry, Eric.
I'm very
You're
hungry. I'm trying to get swole too. But no, yeah, it's just growing, and so as it rapidly grows, it's just consuming more and more and more.
So it gets big and then shrinks and
And
then
it doesn't shrink. It just it gets full.
stops.
And doesn't maybe not stop, but may slow down.
Oh, okay.
It's like, have you ever been to a buffet?
Yes, I've been to a buffet.
Okay, so when you go to a buffet, when you first get there, you probably eat a lot really quickly, and then you get full and you slow down, but then it's dessert time. So you're like,
And
well,
you go right back to
I'm
that
gonna go get some ice cream.
dessert table.
Yeah, so you ramp up again. So that's kind of what they think this rogue planet is doing. Is it's hungry, eats a lot, gets tummy's hurting a little bit, needs some Pepto. It slows down and then may speed up again every 15 to 20 years. When I was reading one thing the scientists thought was fascinating is, so typically when we talk about space, as I mentioned, like hundreds of years, millions of years, billions of years, we're talking about like long stretches of time.
Yeah.
Not per seconds. You don't talk about per seconds in space. Space is big, it's long, it's
Years.
millennia.
Oh,
Wow. It's beyond human comprehension, the tiny ants that we are. This is happening per second. So for scientists to observe something this quick, it's pretty unprecedented for them. Not unprecedented, but rare.
It's hard for them to keep track of it.
No, not hard to keep track. It's just like, what's going on? Why is this eating so much?
Why is it so fast?
Well, what's happening is it got to Golden Corral and hasn't eaten all day.
And then it found another buffet down the street.
It's on another buffet down the street. I was like, I'm going to go down there too. Okay, really? Oh, they have steak and sushi? That's a great combination.
So for some Pepto later.
Get that Pepto and then cool down and go right back at it. Have you ever been on a cruise?
No, actually.
I feel like this is a better analogy. If you go on a cruise, you eat constantly, and then you have to rest a little bit because you want to get up the next morning and eat some more. But you still like order room service at like 2 a.m. and get like a hot dog. And then you eat that and then go back to bed. And then you wake up again. You consume more at
Right
the
back to
buffet.
the buffet.
So yeah, basically this rogue planet just traversing the great starry space is on its own cruise ship looking for food.
On his own schedule, on
I'm
its own
so
time.
happy we came up with that analogy. I apologize to everyone who ever taught me. Anyway, the planet is a CHA 11077626. Write it down. Keep track of it.
What was the name we gave it?
Ro-
Cha-cha.
Rogi Cha-Cha.
Rogi Cha-cha.
Rogi Cha-Cha.
Well, we have another story that we are going to focus on here
Yes,
today.
this one is definitely related to World Space Week 2025. It's a company named Lunasa, or Lunasa. Actually, I haven't said it out loud
Lunasa?
till just now, which is you're welcome. Welcome to the club, everybody. Lunasa is a company located in London, it's a startup. But what they're developing is AI systems that let satellites dock, refuel, and repair each other in space. I just kind of wanted to show off this technology. So they were doing this in a dark room. They actually would turn those lights off when they weren't filming. And the satellite parts would have like cameras and sensors and things, and so that they could handle all of the connection themselves. And so what they're trying to do is figure out ways to grow our satellite industry to make it self-sustaining. Pretty cool, right?
What does that mean by making it self-sustaining?
So right now, not all the time, but frequently, if we have an issue with a satellite that's like really important, we have to send somebody up and they have to go fix it. So what
physically go out there and fix
so
it.
what if we can have the satellites refuel themselves and monitor themselves and like take care of themselves?
Wow.
They handle. I mean, we still have to launch them.
Would someone still need to be like on a computer monitoring that?
They'd probably be
Everything's going
monitoring,
well?
but AI would handle a lot of the technical stuff to handle all that. So we don't have to send a mission up there every time. it's really important that we have these satellites that can take care of themselves because they do so much here on Earth.
Mm-hmm.
And in fact, the company spoke about that, and we take a look at that right now.
Many people might not realize, but anything to do with as small as just your GPS on your phone, or your communications that you do through an internet, or talk to your friend in another country, everything is built around how space infrastructure is. And if one of these satellites get out of their own orbit or get hit by another debris or anything, well, we're going to have problems on ground. And that's not something that we want. So everything that companies like Lunasa are doing is mainly to protect that environment.
So everything that we do here on Earth pretty much has to do with those satellites in there.
Right. The thing you're watching right now does not occur unless our satellites are working. So we don't want to lose our satellites. So if we can keep them self-sustaining, self-maintaining, any way, shape, or form without having a human intervention.
Mm-hmm.
We talk about AI uses. This is something we could really use AI for, to handle these menial tasks, this labor that requires a lot of human work for...
That requires sending humans out of our planet.
I don't want to say like little reward, but like the return on investment for the amount of energy it takes us right now.
It's not good.
It's not good. Like, have to send a person all the way to space to fix something, or launching a new rocket. If we can find, so this company Lunasa is trying to find ways to do just that without us having to be up there. So help with maintenance and things. They're going to do two practice missions, one with Australia and one with France. They're going to have 2 in-orbit demonstrations of this technology to see if it works in space. It could help maintain our satellites in the future. I've actually interviewed a lot of satellite companies over the years, and some of them are doing some cool stuff where they're building like hubs where it's like a central thing that you launch up and people can add attachments to it. And the idea is that one of these can go up and then you could replace a new hub, can come and reattach if there's an issue, and the other parts can migrate. So I've seen stuff like that.
Where does the other part go, like once it's swapped out with the new attachment? In space?
It falls in orbit,
goes
burns
bye-bye.
up. Yeah, it buys it bye-bye.
Wow.
That's another issue we have, that we're trying to, if we can maintain the stuff we have up there now as opposed to launching new stuff, less space debris. And one of the big concerns is we have so much junk. I almost said a dirty word.
No, it's true.
We have so much junk in space.
Equipment, like that's
that
not being
launching
used.
into space is a collision risk, or it could fall to Earth. And so we want to reduce the amount of waste we're putting in space, just like we want to reduce the amount of waste we're putting on Earth. We don't want just stuff everywhere. I don't know. Have you ever moved?
Yes, and I have to throw away so much.
Right.
junk.
And that's like, we discover how much junk we accumulate. And so, and a lot of it is because like, oh, I bought this thing because I wanted to. Anyway, we just didn't like,
Or
maintenance
I
didn't occur.
bought this thing and I kept the box because maybe I'll need it later.
Right.
And it's just junk.
And so we have a lot of that in space that's accumulating. So if we find ways to reduce that by maintaining what we have, just taking care of your car as opposed to buying a new car every 2 years, and that's less junk being put up there. It's better for us as we learn to traverse the stars. Also, for the satellites we need right now on Earth, if they are safer, if they're not being hit by junk when they're in space. So, Gravity. Did you see the movie Gravity? I'm doing a lot of, hey, did you see?
You're throwing a lot of questions. No, I haven't seen.
What you got? So in Gravity, there's a part where like a couple of things get destroyed because they get hit by junk, and so we don't want that to happen. And so if we can maintain what we have up there and adjust what we have up there now, and the next level of things we can, if everything can maintain itself and an AI can help with that, cool beans.
Yeah, cool beans. But AI, we've been trying to use it for a lot of things, and this is the first thing that I think it's really useful for.
I think, let's talk AI. Do you want to talk about opinions on AI? We got a couple more minutes. I think AI is very useful. I think it could get out of hand. It could be very dangerous. But things like, could you summarize this long email chain? I have the new iPhone. I'm not bragging. My old phone broke. But
it has AI in your iPhone?
Yes, it does. And one of the things it does is summarize emails. So in a newsroom, we get, I don't know, thousands of emails a day. And sometimes it's stuff I don't really need to read. It's not related to me. It's just something that was sent to the whole room. Maybe one person interested. Sometimes no one's interested. It changes. We had so much, just junk email all the time. And in a newsroom, you get even more junk email. I have folders upon folders upon folders.
Me too. My email is telling me
stuff.
It has no more storage.
Oh, I'm out too. I have 91%, and I cannot scroll back far enough to archive
All of them.
I want to archive like between 2021 and 2023, and I cannot scroll back far enough to get there. Or I can scroll back, but I can't scroll forward. It's like a whole, and I can't get a rule to work on it. No matter, it's just been a whole thing. Get so much email. Well, now it'll just tell me a summary in my phone.
And is it useful for you?
It is. It tells you like, do I need to actually read this? Or sometimes it's like this person asks you a question. It'll give you like some details, and so that's really useful to me on a day-to-day basis.
With the new iPhone update, one thing that I noticed was when you get spam calls, it makes the person identify themselves like with their voice, and if they can't, then it just blocks the call for you.
Right.
That's what I love.
So stuff like that, super useful. Helping to connect satellites in space, super useful. We use it for brainstorming sometimes when I can't figure out like a word to use in a story. I'm like, God, I'm looking for a word. It means, I brainstorm a few ideas with it and it'll help you. Stuff like that, excellent. Replacing people to do things like artists, not great. Because also the art is like soulless.
Marketing, graphics.
Yeah, things like that, not great. News, great.
Exactly.
It can help us in some ways. I do believe it could be very helpful in some ways in this industry. I also think it could remove the soul of what we do because it is so mechanical. When ChatGPT first came along, I would use it a lot of times to rewrite my emails. And then I realized people weren't I was like, rewrite this, make the grammar correct. But I realized people weren't reading it because it wasn't flawed. If that makes sense. Like it doesn't.
It looked like a robot wrote
it looked like a robot wrote it because
Yeah.
a robot did write it. A robot rewrote the email to make it clean, and I'd reread it and check it. I'm like, okay, this is fine. And it was just emails to send off to like, hey, can you want to do an interview or something? It was those kind of things. And I'm like, I'm too casual in this email. Can you make it less casual? It's stuff like that. And I realized it just took out my soul of what I was writing.
Your little jazz, your spirit.
Yeah, it just like, I use commas very weirdly.
A lot of people love to use
I love
commas.
I love a comma as a breath when you speak.
A pause.
And ChatGPT and Copilot and Grok, isn't that Twitter's? They don't have soul. Anything that requires soul, spirit, human touch, fantastic. Anything that's like menial labor or could you give me a bunch of bullet points, perfect. So I think with stuff like this satellite, helping repair satellites in space, perfect usage. Sorry about popping in everybody's ears just now.
Yeah,
Anyway,
but
that's my soapbox.
When you use AI, aren't you like using up a bunch of water, or doesn't it take like a bunch?
Yes, that's the other thing. It's like high energy intensive. The amount of money you spend every time you tell ChatGPT thank you is astronomical. I'm not kidding.
But some people are scared not to say thank you.
I know because we're worried they're going to come and get revenge on us. But if you tell it thank you, you're costing millions of dollars.
That's crazy.
So don't tell your ChatGPT thank you or Copilot or whatever you're using.
Well, when ChatGPT comes back to get mad at us, we're going to
be polite.
Say Eric said.
You have to be picky on your words. Be polite, but don't tell it thank you.
Yeah.
It's true. It's true. It uses a lot of water, a lot of energy. It costs a lot of money to operate. Can be very advantageous to us as a species, but there are offsets, and everything has a cost.
Oh.
So that's a big takeaway.
I'll
take it back to our and other planets in their solar system and in the other universe parts of the universe that are eating clouds of gas. If that planet wants to grow, it's going to need to go on that cruise.
Oh my gosh.
Yeah, brought it back.
Well, you've made me very hungry throughout this entire stream.
Yeah, I have a nice pasta upstairs I'm looking for. It's like a
waiting
Cajun pasta.
for you.
Yeah, it's good.
We have an article that you have published, and it's on our website, kxn.com. Tell me about the article.
Good photos in there if you want to get a better look at this baby planet and how it's forming. Little extra details. And, of course, I linked the research paper if you really want to dig into it. I know some people do. So it's in there for you.
And that pretty photo of that baby planet.
And the pretty photo and the visualization. And I also have that nice little animation in there we showed you of the planetary disk forming. So pretty cool stuff there.
So if anyone's interested in watching this video back, I know we went on a lot of different directions.
We were on a journey.
We went on a journey this morning.
Like Rogi Cha-Cha did.
Yes, and we are going to do just what Rogi Cha-Cha did and go eat right after this stream.
There you go.
Well, thank you, Eric, for joining me, and we will see you next week.
See you next week.